Now we'll consider one by one different cases regarding spheres. Actually, we are concerned with the capacitors, but then the shape of the conductor is also very important. Suppose you are having isolated sphere like this, the capacity will be 4 pi epsilon naught into R, this one. If you are having two spheres and they are interconnected, but they are not concentric, they are apart and they are interconnected, then in that case you are going to add the capacity of both the spheres. Suppose you are having two spheres and they are concentric, they are interconnected as well. Now what happens in that case? Whatever the charge will be given to the sphere, it's going to be confined to the outer sphere only, because whenever the charge is given to a conductor, the charge is confined to the outer surface only. So in fact, this sphere which is inside and interconnected, it's going to be useless. It is not functional in fact, and that's why only the outer sphere is going to be effective, and you'll consider the capacity as this one. Now, one very special case when there are two spheres R1, R2 radius, and they are at a certain distance from each other as shown over here. In that case, they are like a condenser. You won't say spherical condenser, they are like condenser. Now, on the basis of their energy consideration, you could write U1 plus U2 plus U12. You see, it will have separately potential energy, then by virtue of being a system, also they'll have a term of potential energy that I am writing over here. Suppose the total capacity comes out to be C, then in that case it is Q square upon 2C, Q square upon 2C1, then Q square upon 2C2, and this is going to be Q1, Q2 upon R. We are talking whole thing in terms of CGS system only, and whenever this sphere will be charged, plus Q charge is given, here it will be minus Q, and this Q both are equal. So better you consider both Q1, Q2 equal to Q itself, and that way it will be getting cancelled, multiplied by 2, then you finally get 1 upon C equal to 1 upon C1, 1 upon C2 minus 2 by R. This is the capacity of this type of condenser, which is not given any specific name. Now another type is cylindrical capacitor. Suppose the cylindrical capacitor has two coaxial cylinders, each of length L, having radii A and B. Then when the this inner one is given the charge will be induced on the inner surface of the outer cylinder. Outer surface will be assuming similar charge that will lead to earth because connected with the earth. Then in that case the field is going to be between the two cylinders only. Between these two cylinders only, there will be field. It will be radially outward. If you are giving positive charge to the inner cylinder, in that case, the capacity is going to be, it's given over here, 2 pi epsilon naught L upon log base E, ratio within bracket would be V upon A. You see, one important thing you have to notice, that capacity is directly proportional to length of the condenser, which is in fact cylinder. Underground cables, all the underground cables, whether it is submarine cable or cable in the manhole, even that also, all the underground cables are better example of this cylindrical capacitor. Here you might say the field is hyperbolic because by the cylinder the field is given according to this relation, in which you find E is proportional to 1 by R.